I'm going to show how to make this cube wall using Affinity Photo's procedural texture filter. I tried implementing this a few different ways and I finally found this way, and I think this is one of the easier ways to implement this pattern. If you look at these are actually hexagons, but they're shaded in a fashion to make them appear as if they're three-dimensional cubes. I think I first saw this pattern in the works of M.C. Escher. It was also used in an early computer arcade game called Qbert. I'm going to be using a type of polar coordinates that were suggested by the Art of Code. I'll put a link to Art of Code's video in the description for this video. I want the 0 position of the angle to be down here. Then I can just apply a gradient map to get the colors set up in this cube fashion. I'll start with a new 1024 by 1024 image. Make sure it's an RGB, and I'll fill that with black. I will add a live procedural texture filter. I'll start with a single equation and assign it to all 3 channels. And I'll add a single real input A. I'll just bring that up to 6. So I'll start by creating a hexagonal grid. For the hexagon grid, I'm going to create 2 rectangular grids, blank out one of them with the hexagon shape, and then blank out the other one with the hexagon shape and add them both together. To get the correct ratio for my rectangular grid, I need to create this scaling vector based on 1 and the square root of 3. I'll start by creating a scaling vector, variable sv equals vec2, with 1 and the square root of 3 as the 2 elements. I'll create another variable for the coordinate system. I'm going to call this one v0, and I'm going to have it be a vec2 of rx comma ry times a divided by h, the height of the document in pixels. A is my custom input scaling factor. I'll call that scale. So I have that. I can drag this around to get this into position. If I bring this down to 1, it'll reach its full value right down in this corner. It goes from 0 to 1 here, 0 to 1 over there. Next I'm going to create another coordinate vector v1, and this one will be the first of the 2 that I'm going to combine later. So this one will be the fraction of v0 times the scaling vector sv minus 0.5, and then to return this to a uniform dimensions I've got to divide by sv over here. Next I'm going to have another variable, just like this one, v2 equals fraction of v0 times sv, and this time I'm going to add 0.5 in here, and that will shift it over relative to the first one. So this will be minus 0.5 over here, same as before, and then divide the whole thing by sv. So this creates another one, shifted over from the first one. Then the last part will be to create another variable. I'm just going to call it v this time, and this is based on a step function. This is where I block out the 2 types of hexagons. So I'll have one row of hexagons associated with one coordinate system and another row of hexagons associated with the second coordinate system. I make that hexagon shape, or the mask for those coordinate systems, using the step function, and what I put in here is length of v1 is going to be the edge of the step function, and then length of v2 is going to be the value that I'm stepping with, and then I can multiply that by my this one by v1. And if I look at that, you can see it's forming a nice half of a coordinate system. And now I do the same thing. I'm just going to add step of length of v2 by length of v1, and then multiply that by v2. And there's the other half of the coordinate system. Now I've got the full hexagon tiling of the plane with a coordinate system in each cell. Next thing I'm going to do is to set up a polar coordinate. So my polar coordinates, which are based on the radius, the length from the origin, and the angle, and you can access any position on the plane using the radius and the angle. But now I'm going to set it up as a vec2, just like we do with our other coordinates. So I thought that was pretty interesting to do it that way. So I'm going to do var vp, and this time I'm going to use vec2, and I'm going to have this be a tangent 2. So take the arc tangent. To get the angle, I'm going to use arc tangent of v dot y, which is my hexagon coordinate systems, and then v dot x, and I'm going to divide this by 360 degrees. Now, the arctangent 2 function will return a value of the angle between minus 180 degrees and plus 180 degrees. Now, that will give me a value that's between minus 0.5 and 0.5. And for the second element of this vec2, I'm going to put in the length of v. So now if I look at that, I'm going to zoom in on this. I have the angle starting over here at 0 and going around this way. Now I'm used to seeing an angle starting at 0 in the positive x-axis and then going around in the opposite direction. In this case, I'm starting at the negative x-axis and going around in a clockwise fashion. So it's increasing in a clockwise fashion. And then with the green element, you can see that's dark at 0 and goes up to approximately 1 when you reach the edge of the cell here. The next thing I'm going to do is just quantize based on 1 over d. And I'll add a d element in here of vp.x. So I have to add my d value, and I'm going to bring this up to 3. And I can start to see something on the screen, but it doesn't look too good. So one of the things I notice, let's see if I bring this up a little bit more. Okay, so there I can start to see the hexagon shape again, and it looks a little off. So I would like to add, shift this over a little bit, and so I'm going to add a angle input so I can shift this. I'll put in pH, I'll call it pH for phase or phi, and I'm just going to have this as a phase offset, and I'm going to set this up to add on a phase value plus pH divided by 360 again. Okay, so now I can add my phase onto this. So let's bring that up there. So now I can bring it all the way around. So now I can change my D value. What I'd like to do is to divide this into 3 different parts, and each one will be a different shade value. So I'm going to try bringing this back down. There's 4, there's 3. Okay, so now I have my cube wall that I was looking for. If I bring this to 2, I have quite a few values here. So one way I can adjust that so it's a little bit closer to 2 across scale is if I normalize my scaling vector. So I'm going to do that. I'll just put in a norm on that one and change that one so it has normalized value. There, that's about 2 hexagons across approximately. If I'm looking at this as a wall of cubes, if I look at the hexagon shape that's making up these cubes, I want the points of the hexagon up. I tried a few different ways, and this way seemed to be one of the better ways to do it. I'm just going to bring this up so I have quite a few of them here so I can see the hexagon. I'm going to use a vector manipulation function, and it's called swapxy, and this will swap the values of x and y. I'll just apply this to my entire v0 coordinate. So now I have this black one up here, and it goes round, which is close to what I want. But what I really would like is to have this edge down here at the bottom and then have it go the rest of the way around. So I'm going to change the RY to a minus RY. Okay, and when I did that, my whole pattern went away, but if I double click in the middle, since it's RX, RY, then I can drag it over here, and now I can see I have this dark line down at the bottom, and then it goes around this way, and I'm just going to go with that. I should be able to use that to create my 3 different regions with the quantize effect. So I'm going to bring this back down to 3. So now I have black over here, I have sort of a dark gray here and a light gray there. I would like it to be black, gray, and white, and I found out that I can adjust quantize if I scale it by a certain factor, and that factor is d divided by d minus 1. So I'm going to multiply by this scaling factor where I'm using a quantize of 1 over d, and then I multiply by d over d minus 1, and that will always bring it back into the range from 0 to 1. I've got the range now, so now I can add a gradient map to this. So I don't have to have these in the same order. You know, this one was the darkest one, this one was sort of gray, and that one was the lightest. But I can change the order of these now using the gradient map. I'm going to make this one sort of a pale yellow, and then this side I will make sort of a pink color, and then this one I'll make sort of a smoky blue color, like that. Just review the final formula. I start with my scaling vector, which is normalized vec2 of 1 comma square root of 3. Then I have my initial coordinate vector. In this case I'm starting with a swapxy, then vec2 of rx comma minus ry times a over h. And that turns my hexagons to the correct orientation. Then I create a fraction of that, fraction v0 times sv minus 0.5 over sv, and then I do another, and this is pretty much the same except that inside the parentheses of the fraction I'm adding a 0.5 to that. Then I block out the different hexagon shapes with this formula. I use step of length of v1 comma length of v2 times v1. And then I use step of length of v1, length of v2 times v2. Next I'm creating a polar coordinate system from the hexagon measurement, and I'm calling that vp. It's equal to vec2 of a tangent 2 of v dot y comma v dot x divided by 360 plus my phase offset ph divided by 360 comma length of v for the second element of that vector. And then I'm just doing quantize of 1 over d vp.x times d over d minus 1. The final custom input panel for this filter has a real value a for the scale, a real value d for divisions, and an angle input ph for phase. Custom input A is used to determine the number of cells, so if you want more elements, make this number bigger. Then D controls the number of divisions. Just set this to 3 if you want to see the cube effect. Phase is set to an offset of 180 degrees. There are a number of variations you can do with this pattern. You could use it as a mask to mask out certain regions and then apply specific effects to certain faces of the cube. Alright, so that's the wall of cubes effect. Let me know if you have any comments or questions, and thanks for watching.